right, as we begin our lesson today, we're going to continue with our ACT prep. There was the handout that was attached or in the description of the previous video. Obviously, those in the class have the printed handout. But we're going to do the second page, which is problems 6 through 9. Problems 6 through 9 of that document that was in the description last time. You see a little geometry on here. Okay, so you go and get started. You have 4 minutes to work on these 4 problems. Just about another minute or so to be finishing up. Time is up. Were we able to finish all 4? You were, and Ethan's finishing his last one. He got his verdict in. All right, so we'll go to Quentin first of all. Quentin number 6, in that figure, EF was constructed starting from rays ED and EG. By using a compass, D and G were marked equidistant from E, and then the compass was used to locate point F distinct from E, so that F is equidistant from D and G. What is true of the measures of angle DEF and angle GEF? F, they are equal. In other words, that's the construction of an angle bisector from geometry class, right? So you kind of look at it, you kind of look at the picture like, that's an angle bisector. What's true about those two angles? They've got to be equal. All right, number 7. Abandoned mines frequently fill with water. Before an abandoned mine can be reopened, the water must be pumped out. Size of the pump depends on the depth of the mine. If pumping out a mine that is D feet deep requires a pump that pumps a minimum of D squared over 25 plus 40 minus 250 gallons per minute, pumping out a mine that is 150 feet deep would require a pump that pumps a minimum of how many gallons per minute? D, and that's just all calculator, right? You plug in the 150, square it, divide by 25, plus, and then 4 times 150, and then subtract your 250. That's just how you got to get the answer on that one. All right, letter D is our answer. Number 8, the length in inches of a box is 3 inches less than twice its width. Which of the following gives the length in terms of the width of the box? Letter K, 3 less than twice. Twice would be 2W, 3 less than that would be 2W minus 3. So there's your answer for number 8, just algebraic representation. And number 9, in that quadrilateral, sides PS and QR are parallel. For what value of X? I was asking Quentin. That is correct. D, 110 degrees. Is that a parallelogram, class? No. Look at those two angles, P and S, 70 and 112. Is that up to a straight angle? No, so definitely not. Yes, sir.
I don't know exactly how to do this.
You just take each of what I gave you in degrees and change them all to radians. Everything that's labeled, like my numbers, change each of those to radians.
Just the ones that are labeled?
Just the ones that are labeled, yeah. All right. So definitely, so it's not a parallelogram, but it says PS and QR, the two sides can be parallel, which would make it a trapezoid. Little geometry review there, right? And make it a trapezoid if those two sides were parallel. But for that to be true, Q would have to be 110 degrees. So good. Quentin got them all. Jamie, how'd you do?
I got them all.
Got them all. Also just a hair behind Quentin. And then Ethan, how did you do?
It's like 3.
Ooh, okay. Do you understand the 3 you missed, or do you have a question?
I just don't understand 6.
Number 6. And number 6 was the very first one. Okay. The question is, do you see angle DEF on the sketch? Do you see angle GEF? The question is, what's true about those two angles? Well, do you see that that construction is the construction of an angle bisector? So if it's an angle bisector, what has to be true about the two pieces of angle formed? Have to be equal. That's all. Almost stupid easy. I mean, you almost spend more time reading the problem than you do just figuring it out, honestly. It's a lot to read, but they have to be exact and specific, and this is what happened. But you just look at the markings. They made an arc through, except they didn't make the whole arc, right? Like we're used to seeing the entire arc through. They just cut a little arc through, lifted the compass, little arc through, pick up the compass, little arc, connect the dots. Angle bisector, they're equal angles. Stupid easy, right? Does that make sense now?
Not really. It makes sense now, but like when I was reading it, I was like confused.
Sometimes you can confuse yourself more by reading. Almost like on the mine problem. Okay, on the problem about the mine, it's all this big, long whatever. The bottom line is, you look at the equation, and it says the mine's 150 feet deep. That's your D. So you plug in 150. That's all you do. And it almost takes too long to read the problem. However, I will say, if you don't read the problem, sometimes you get burned. I just took the updated practice test, and one of the problems I missed because I didn't read it carefully. And I put an answer that was a partial answer, but it wasn't the final answer. I didn't do the last step because I didn't know to do the last step because I rushed through and didn't read. So yeah, I'm even guilty of that sometimes. Yes, sir?
So on the ACT test, will they have diagrams like this, or will we have...
These diagrams are their tests. These are their diagrams. This is actually straight from the ACT website. Yep. This is official ACT prep, not stuff I made up. Yes, sir. Yes, ma'am.
So I'm assuming the math, it seemed like for number 9 it would come out to 108. Did they change it to 110 for suffix or?
No. Okay. So yeah, good question. So on this one here, these are the sides that they want to be parallel. Ignore the other stuff. Bottom line, for these two lines to be parallel, this angle has to be supplementary to the other interior angle. So if this angle's 70, you have to have a 110 to finish the parallels. Does that make sense? This line is not parallel. Okay, this line kind of goes down more compared to this one. But these two, to be parallel, have to have supplementary angles on the same side of the transversal. So that's where you get the 110. Does that make sense?
Yeah.
Good question. Good. Any other questions on this? Some good geometry in this one. I had a couple of geometry problems. One algebra and then one just plug in the number kind of thing. All right, set that aside. Again, I would hold on to those, and we'll continue working on more ACT prep. Now, tomorrow we'll take a break from ACT prep. Y'all have to dismiss class a little early, remember, for Pizza Day. If you're watching on YouTube, you have no idea what that is. But I'm going to have to dismiss them a little early. So tomorrow we'll take a break from ACT prep. We'll come back in the next lesson and finish this first handout that I uploaded to YouTube. All right, let's go ahead now and turn to your homework, pages 46 to 47. Pages 46 to 47. You did numbers 2 through 14 even, and there was an equation I gave you yesterday. And there's just going to be a few equations for you to memorize. This is going to be one of them. An equation that helps you, or a formula that allows you to find the length of an arc. Not the degree measure of an arc like we talked about in geometry, but the actual length of an arc. And I said, we couldn't do this in geometry last year. You didn't know about radians last year. But now that we understand radians, you can find the length of an arc using what formula, Ethan?
Keep pi over 180.
You're thinking converting degrees to radians. What's the formula to find the length of an arc, Jamie?
S equals R
Oh, yeah.
sine, or was it theta rad?
There we go. S equals R theta rad, where S class stands for
Arc
arc length. R stands for
radius.
radius, and theta rad stands for the
Angle.
central angle, or the angle of rotation in radians specifically, hence the rad that I supplied. That's just to remind you, it has to be radians, not degrees. Number 2, you were given the radius, you were given theta rad. All you had to do was multiply. And what did you get for your arc length? Quentin?
36.3. Well, 36.26.
Good, because we have 4 sig figs in number 2, so 36.26. Length is going to have this unit on here, and it's going to match the radius, so millimeters. There we go, 36.26 millimeters. Number 4 is obnoxious, because they give you theta, but it ain't theta rad, it's in degrees. What do we have to do, Ethan?
Convert it to radians.
By multiplying by?
Pi over 180.
Good, so we're going to have to take those 12.25 degrees times pi, divide by 180, then multiply that theta rad, which is a weird decimal, times your radius, which has 3 sig figs, to get what answer for number 4?
9.99 kilometers.
I had 9.98 kilometers. I didn't have it rounded up. So I'm not sure if I had, did you have 9.98 or 9.99?
9.98.
Okay, so maybe a little rounding error there, but otherwise seems like we did everything correctly. Good job on that one, 9.98 kilometers. Number 6, they're asking for the central angle in radians. How do I rearrange this equation to get the central angle by itself, Quentin?
R equals S over theta rad.
I'm finding the central angle in radians.
Theta rad equals R over S.
How do we get theta rad by itself?
Oh, S over
S over R. Good. So again, just rearranging the formula. So for this problem, all you got to do is take S, divide by R, 25 inches divided by 15 inches. What happens to the inches, class? They cancel. So what's your unit? Nothing. If you want to say radians, you can, but there's technically no unit at all. What do we get for our answer, Quentin?
1.6.
I got rounded up 2 sig figs.
1.67.
Why? 1.7 when you round. 1.7 radians. Number 8, same type of thing. Divide the S by the R, and we're going 3 sig figs this time, Ethan.
0.26.
Well, that's 2 sig figs. We got 3 because you're 112 and 432.
I
So,
don't know what that thing was. After third.
Jamie, did you get it?
0.259.
0.259 would have been the properly rounded. So again, just account for sig figs in these. Number 10, you were asked for the length of the radius of the circle. Ethan, how do I rearrange this equation to solve for the radius?
Radius equals theta rad over S.
So to get the R by itself,
You divide by. So R equals S over theta.
S over theta rad. Again, we don't have to guess at how to rearrange it. We know how to do algebra. Go ahead and make sure to divide away the correct thing you don't want anymore and get it by itself. So this is the equation we're shooting for. We're going to take the arc length, divide by theta rad. Number 10, they give you the arc length. They give you the theta rad. You just divide. Jamie, you get?
11.
Well, I've got 3 sig figs.
11.0.
11.0 meters on number 10. Number 12 is obnoxious because you've got your S, which is your 26.0 miles, and you're dividing this by theta rad, which is 5 pi over 8. Do you see the complex fraction? A couple ways you can handle this. You could multiply by the reciprocal 8 over 5 pi. That's still pretty obnoxious. So here's my strategy tip. Here's my recommendation. Use parentheses around this. On the calculator, 26 divided by, parenthesis, 5 times pi divided by 8, close parenthesis. That's my suggestion. Do we know how to use parentheses on the calculator? What do we get for our answer then? What's the radius of the circle? 13.2 miles. How many got the 13.2 last night? Excellent. Quentin, you did not. The other option is to put 5 times pi divided by 8 in the memory. Get whatever value it is, and then take 26 divided by memory. That way you're not accidentally messing it up, because if you do 26 divided by 5 times pi divided by 8, it's going to screw everything up, okay? You've got to use parentheses to do it, okay? Because otherwise you're literally 26 divided by 5 times pi. Well, the 5 times pi is what's being divided, right? And then divided by, it's just a big mess, right? So we've got to put the parentheses around all this, or find what it is in the memory first. All right, questions on this? By the way, let me show you the other way. Remember I said you could multiply by the reciprocal? 26 times 8 over 5 pi. If you do it this way, you're going to want to do 26 times 8 divided by 5 and divided by pi. Now your calculator, you might be able to do divided by 5 pi. You might actually be able to just straight enter that. But for you guys, you can't. So you want to do 26 times 8 divided by 5 and then divided by pi as well. Parentheses, memory value. You know, so one of those I think is probably the easier way to work it. Finished? All right. Let's go and take a look at number 14 now, and go and read that word problem, if you would, Jamie.
An arc measures along the edge of a piece of pizza is 6.28 inches, and the central angle is 24 degrees. Determine the diameter of the pizza.
All right, so we have pizza, big pizza. And we know that there's a central angle of 24 degrees, which is a very thin slice of pizza, okay? But the arc is 6.28 inches, which that number should be like, that looks really familiar. 6.28, class?
2 pi.
Yeah, so now it's rounded, so it's not exactly 2 pi, but about 2 pi inches in the radius, in the arc length. So there's my S. My theta is 24 degrees. Anyone got a problem with that? Yeah, you gotta have radians. So we multiply by pi, divide by 180, and that'll give me my radians. And then I'm asking for, it didn't ask for the radius, it asked for the diameter. But a diameter is simply equal to 2 radii, right? So if I find the radius and then multiply that by 2, I'll get the diameter of the pizza, which is how pizzas are always listed, right? A 14-inch pizza means 14-inch diameter. Okay, so to find a radius, we take this equation. We're only going to memorize it this way. We're not memorizing 3 equations here. I ain't got memory space in my brain for that. I'm memorizing this, but I'm able to manipulate it by dividing the theta rad from both sides to get S over theta rad. So take the 6.28, divide by the memory value, hopefully, and that'll give you a radius of
14.992.
14.9 blah, blah, blah. You multiply that by 2 to get the diameter to get 30.0 blah, blah, blah. And then here's where it's hard. 24 degrees is only 2 sig figs. So I could make an argument for 2 sig figs and say it's 30 inches diameter, which is a massive pizza, by the way. I'm curious now. How close to accurate was I? This is only a 28-inch diameter pizza, so it's actually a couple inches bigger than this still. But anyway, so huge pizza.
Looks like a good pizza.
I know, it's just one of our dreams, right?
Pizza, my favorite.
Right, and a chalk pizza, yes. And then, or I could make the case for, well, since this is being multiplied by pi over 180, we're converted to radians, so that's kind of messy. So I can also see a case for going 3 sig figs 30.0. Yeah, either way, 30 inches. It's a 30-inch pizza. How many got 30 inches on the pizza? Okay, Jamie did. Gentlemen, questions?
I got 3.82.
I get it now.
You get it now?
Mm-hmm.
I got 3.82.
All
I
right.
get it.
I have it. I don't know what I did.
We'll go back and watch the video, frankly, at this point.
Oh, I did. No, I did. I watched the video last night.
All right, did you do that?
Mm-hmm.
Then that's why you didn't get it. Got to do that. I'm going to pause the video here for just a little bit while we take a look at the extra credit. If you were watching on video, though, send the extra credit to me. Well, unless none of you did it. How many tried the extra credit, number 15? They did try it. We're going to pause the video. We'll be back.